Today we're going to learn how to graph two tables onto the same graph. We're also going to kind of review writing equations from tables and all that kind of stuff. All right, so we're just going to do one example together, and then I'll have you do one example on your own. All right, so the first example we'll do together. Keegan works part-time at a clothing store. He earns $5 just for showing up, as well as $10 an hour. Keller works part-time at a different clothing store, and he only earns $12 an hour. So he doesn't get that amount of money just for showing up, but he does get paid more an hour. First, we're going to determine the independent and dependent variables. So we're looking at the number of hours worked and the money earned. Remember, for that dependent variable, we want to use that phrase blank depends on blank. Okay, so our dependent variable depends on our independent variable. So the amount of money that they earn depends on how many hours they work, since they get paid each hour. So our money earned is our dependent, and our hours worked is our independent. All right, so we're going to start by making a table for each of them. So let's start off with Keegan's. Okay, then we need to label each column. Our independent, our X always goes on the left, remember? So that's our hours. And our dependent, our money, should go on the right for both Keegan and Keller. So we can set up those tables the same right away at the beginning. Okay, for Keegan, if he works 0 hours, remember we always start our tables with 0. If he works 0 hours but he shows up, he still gets $5. Okay, if he works 1 hour, he gets that $5 for showing up as well as that $10 for that 1 hour. So he would get $15 total. If he works 2 hours, he'd get that $5 showing up plus $10 for each of those hours, which would be $20 plus that $5, $25. And if you can start to see a pattern, you can complete the rest of this table. All right, if we're just using X and Y, remember our equation is always y equals because our dependent variable is what it's equal to. So the money he earns is equal to however many hours he works times how much he makes an hour. So 10x will tell us how much he works for making each hour, how much he makes for working each hour. And then we have to add in that $5 that he gets for just showing up. So our equation would be y equals 10x plus 5. Now for Keller, again, we're going to start with 0 and want to count up for those hours. But he just makes $12 an hour. So if he doesn't work any hours, he doesn't get any money. If he works 1 hour, he gets $12. 2 hours, 24. And you can continue to build your table. Our equation here is always going to be y equals the money that he earns is going to be equal to 12 times however many hours he works, so 12x. All right, now what we are going to do to graph these points is we're going to choose a color or a shape for Keegan. So I'm going to say just like red dots for Keegan. Or if you don't have colors, you could just do dots for Keegan. And then for Keller, I'm going to do blue triangles. Okay, or if you don't have colors, just doing different shapes helps out if you don't have colors. Otherwise, you could do red dots and blue dots, however you want to go about that. Stars, really up to you. So let's go to Keegan. We have to look at the bottom. We're going to be going 0 to 5 on both of them. Okay, so I'm just going to skip a line. Oops, skip a line just to spread this out. So that it's not all just scrunched right here. You don't have to do that, but it's just going to make my graph look nicer. Then for my y-axis, I have to look at my y values, and they range from 0 to 60. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can count by fives, and I'd be able to fit 60 on there. Okay. You could also count by tens. It's just that your graph would be really crammed. So counting by fives would probably be the best scale for this. So let's go through and let's just plot Keegan's. Remember, he's our red dot, so at 0, we should put a 5. Should go up to 5. At 1, we should go to 15. At 2, we should go to 25. At 3, it's going to be 35. 4, 45, and 5, 55. We're then just going to connect those dots for Keegan's line. Okay, then on the same graph, we're going to do Keller's. Okay, so we'll be at 0, 0 for Keller. Then we'll go 1, 12. You can kind of just guesstimate where 12 is to the best of your ability. 2 would be 24. 3 would be 36. 4 is 48. And 5 is going to be 60. Okay, so the point of graphing these on the same is because it's going to kind of show you that yes, Keller starts off making less money than Keegan does because Keller is that blue line, but then they hit a point somewhere around here where Keller starts making more money than Keegan does for working the same amount of hours. Okay, a question on a quiz or test might ask you, at what point does Keller start to make more money than Keegan in terms of hours? And we could figure that out from our table here. At 1 hour, Keegan's making more. At 2 hours, Keegan's making more. At 3 hours, Keller's making more. So you would say like at 3 hours, Keller would start making more money than Keegan. Okay, and it would probably be somewhere around like 2.5 hours, but we just want full hours. So at 3 hours, Keller would start making more money, which you can see on that graph at 3 hours is where Keller started having a higher value than Keegan. They might also ask you an extension question like letter E is asking, if Keegan and Keller both work a 12-hour shift, who makes more money? So we are going to use our equation. So Keegan's is y equals 10x plus 5. Remember, x is equal to the number of hours they work. So to find out how much money Keegan would make, we just plug in 12 hours for our x to solve. Oop, that's a plus, not a times. In our order of operations, we'd have to do that multiplication first. So 10 times 12 is 120 plus 5. So Keegan would make $125. Let's put his name there so we don't forget who is who. And then Keller, his equation is y equals 12x. We just multiply. This is Keller. The number of hours times how much he makes each hour. So we do 12 times 12, which would be $144. So our answer to this would be Keller makes more money because he makes $144, where Keegan only makes $125. Okay, in that explanation, we would want to use those dollar amounts so that we would know we're giving some sort of proof. Okay. All right, so that's the example we did together. I want you to pause the video and try this next example on your own. Then you can resume the video to check your answer. So right now, if we are watching, we should have this problem completed. So I'm going to go through this a little bit faster than normal. If you have not yet completed this problem, pause this video and only resume when you are done with it so that you can check your answer. You can buy a 12-pack of Gatorade at King Soopers for $10. At Sam's Club, you pay $12 to join, and then you could buy the same pack of Gatorade for $7. All right, so the independent, dependent cost. Well, the cost is going to depend on how many packages of Gatorade we buy. Okay, that total cost that you're spending is going to depend on how many Gatorade packages you buy. If you only buy one package, you're going to pay a lot less than if you buy 100 packs. All right, so we have King Soopers, Sam's Club. We have our independent on the left, that's Gatorade, and our cost on the right. Remember, that's our X and our Y. We have Gatorade and our cost, our X and our Y. We always start with 0, And these are 12 packs that we're talking about, but we don't need to know how many individual Gatorades. We're just talking about packs of Gatorades at this point for the 0, 1, 2, 3, 4. So if you buy a King Soopers 0 packs of Gatorade, you're going to spend $0. If you buy 1 pack of Gatorade, you're going to spend $10. If you buy 2, you're going to spend $20, and so on. You can see that pattern. At Sam's Club, you're paying $12 to join. So if you buy 0 packs of Gatorade, you're paying them still $12. Okay, but then if you pay them that $12 and buy 1 pack of Gatorade, that's going to be $19. If you buy 2 packs of Gatorade, that Gatorade's going to cost $14 plus that $12 that you already had to join. So we do 14 plus 12 to get 26. You might see a pattern. We're just adding $7 for each new pack of Gatorade that we are buying. So this would be 33, 40, and 47. Okay, so you're going to see that King Soopers starts off. Oops, Siri's trying to hang out. At King Soopers, the amount of Gatorades you buy start being less expensive, but then we get to 1 point, and that's why I like this example, because we get to 1 point when they cost the exact same. Okay, so if you so we'll get to this. It's going to ask us this later, but just notice how if you buy 4 packs, it's going to be the exact same. We'll see that on our graph. Again, I'm going to use blue dots. I think I actually messed that up. I think I used red dots above. Blue triangles, yep. So I'm going to change that up. I'm going to use red dots, blue triangles, in order to graph both of these on the same graph. All right, so King Soopers, oh, we have to label our graph first. Sorry, I'm getting ahead of myself. Go 1, 2, 3, 4, 5. Again, I'm going to skip a line just to make it look a little bit better. My Y's are going from 0 to 50, so I would count by 5s probably. All right, for King Soopers, I am using a red dot, and I'm going 0, 0, 1, 10, 2, 20, 3, 30, 4, 40, 5, 50. For my Sam's Club, I am 0, 12, 2, 20, that's not what I wanted, 1, 19, 2, 26. So you're going to see how it starts off being more expensive. 3, 33, 4, 40, 5, 47. One thing I forgot to do with my red line was to connect it into a line, so I'm going to want to go back and do that. And you're going to see that King Soopers starts off being less expensive, but the more packs that you need to buy, Sam's Club starts to be less expensive. There's a turning point right here in which they're the exact same price. You can see that on your graph. I also showed you how you could see that on your table. So how many packs of Gatorade would you have to buy in order for Sam's Club to be the cheaper price? So for Sam's Club to cost less, it would be the exact same at 4 packs. But for that blue line to cost less than that red line, you have to buy more than 4 packs. So it'd be more than 4 packs. And then you would go on to just say, because at 4 packs they would be equal, at 5 packs Sam's Club would only cost 47, whereas King Soopers would cost 50. And this is basically the reason why people get those kinds of memberships, is because if you're buying in bulk, meaning you're buying many of something, it's cheaper to go to like Sam's Club or Costco. I also just realized I forgot to do my equations. Over here it should be y equals 10x. Over here it should be y equals 7x. $7 for each pack, plus the $12 to join. Over here is just $10 for each pack. All right, and that's it.